It's my privilege to introduce our next keynote speaker, Anthony Behan. Anthony Behan is the Managing Director for Communications, Media and Entertainment at Cloudera. He is an industry-recognized innovator and an evangelist for the power of data and AI. Anthony was previously an executive industry leader at IBM and held leadership roles in telecommunications software companies in Europe and North America. Hi, Anthony. We warmly welcome you to our AI Forum. Over to you to enlighten our viewers on the data architecture for Metaverse.
Well, good morning and thank you all very much. It's wonderful to be here. Wonderful to have the invitation to speak to you today. I'm going to try and say a few words about the Metaverse. First of all, I know you've been talking about the Metaverse over the last couple of days, and everybody's trying to learn more and more about what exactly it is and what the implications are for our industry and for the world more generally. And then I'm going to try and put a spin on it specifically around the telecommunications industry, what it means for our network and for our business. And then even more specifically, what it means for our data. Because clearly we're in an age now where data is powering our business, where data is essential for the models that we build to drive automation and so on. And so what are the kinds of data that we should be expecting, and what are the architectures that we need to support the data, the likely data sets that we're going to be getting? What are the guardrails going to look like, and so on and so forth. So let's get into it a little bit. So first of all, when we think about what the Metaverse is, it is something that kind of escapes definition in one sense. It's kind of a bucket of future information communications technology that we can put a lot of things into. When I was preparing for this, I was trying to think, well, okay, how can I capture, the Metaverse in an image? And I found this wonderful little tool online, and I couldn't avoid putting it in here and just recommending it to all of you. The link is there, and I'm sure that the charts will be shared afterwards. But it's a web service called Hugging Face, where you can put in a unlimited text, whatever text you like, and it will, using artificial intelligence, create an image for you. And this is the image it came up with, and I love the image. I think on the one hand, it's a very beautiful image with a human at the center of it, or something that looks kind of human at the center of it, and a whole bunch of kind of organized chaos around it. And I think it's a fairly good metaphor for what the Metaverse, what the Metaverse is or could be. There's a lot of connections, there's a lot of devices, there's a lot of services, there's a lot of everything that goes into this. And it is a kind of a fusion of all of these technologies to hopefully drive better human experience. And at least that's what I read from the image. But you should try that little service. It's quite an inspirational little tool. It's one of the things about these technologies is that they're already here. I love this quote. I'm sure you've heard it before from William Gibson. He's written a lot of very prescient books. He's got a program on TV at the moment called The Peripheral, which is pretty good. You should go watch that if you can see it. But he said the future is here. It's just not evenly distributed. And what he meant by that was, look, all of these technologies that we talk about, they exist, most of them. So if you think about flying cars, for example, you might say, well, that's future technology, it doesn't exist. Well, do a Google search on flying cars. You'll pretty quickly come up with a few different versions of it, and demos, and people getting into cars and then flying them away. And some of them look like drones and so on and so forth. But the point is that, the technology is here. It's just, there's only one or two of them out there, and so it's not necessarily in your backyard, but it's in somebody's backyard somewhere. So and a lot of the ideas that go into the Metaverse around artificial reality, virtual worlds and constructed environments, digitally constructed environments. These ideas have been around for a long time in the world of fiction, if not in other places. So this little graphic, by the way, comes from a report from Arthur D. Little, which is really, really useful. Again, the link is there in the bottom right. A lot of these, many of you will have read some of these novels. If you haven't, you should go back and read some of them. There's, in the middle there, you can see Arnold Schwarzenegger from Total Recall. again, a kind of a, where you plug into a machine and you go on holiday in your brain. A lot of the ideas in that will really sort of help you to think through what the implications of some of these kinds of technologies are, because a lot of the time when we speak to companies, particularly who have an interest in the future of the metaverse, they're not really going to take you through all of the, the potential side effects, and these novels tend to do that. That's what gives them the tension, I guess. So a bunch of stuff in there that you can get yourself into. So we've seen all of this stuff. These ideas are not new, but they're coming together. And what that also tells you is that this isn't really a story about technology. Certainly technology is important, but what this is really a story about is people and politics and commerce and trade, and how we work with each other and how the world functions. And so it's about how we can evolve our interactions with one another to be in some sense better. At least that should be the objective, and the metaverse hopefully can realize some of that. Fundamentally, though, we get down to it, what really the core technologies in the metaverse are augmented reality, virtual reality. These technologies that obviously have been around for a long time, but that are maturing now quite significantly. We're starting to see them emerging as mainstream technologies. They're better distributed. If to just take on William Gibson's phrasing. There's more of them around, and then the services and the software that are some of the things that are useful. We think about things like virtual meetings. We're having a virtual meeting right now. This wouldn't have been possible 20, 30 years ago, certainly not at scale and the kind of scale that we're doing right now. But it's still a virtual meeting, very obviously. We're disconnected from one another. Many of us are sitting in our homes right now, and very obviously so. This kind of virtual reality can give us this immersive experience where we can see avatars of other people. They're very lifelike. They're not just like the sort of the Sims of or Second Life or something like that. They're far better realized versions of ourselves than have previously been the case in virtual worlds. And we're sitting at a table and we can lean in and whisper to people about things and so on, like you could do at a normal meeting. That sort of experience is kind of what we're going after. Businesses like real estate will clearly benefit. We already see on real estate websites a lot of sort of 3D videos of homes and properties that are up for sale, so that you can do a tour of the property from your living room. There's a more immersive experience becomes possible with VR. Shopping and commerce and so on is another one. Again, going back to the world of science fiction, if you've seen the Tom Cruise version of Minority Report from, I think it was 2001, again, based on a Philip K. Dick short story from 1956, if I'm not mistaken. There's a sequence in that where the hero runs through a shopping mall and is accosted by a series of digital signage that recognize him as a person, and that also recognize his vital signs. And he's running away from the cops, so he's sweaty and flushed and so on. And so one of them suggests that he could do with a Guinness right about now. And then he runs into a department store and they recognize him and so, how are those tank tops working out for you and stuff like that? And sort of, and this technology is very much in place right now. There are stores around the world that have, mirrors that you can stand in front of in the physical store, and will place the clothes on you and make, so when you look into the mirror, you see yourself with those clothes on and things like that. So augmented reality in action there. And of course the world of gaming. Gaming is at the vanguard of a lot of these technologies, and as is often the case, gaming is really enjoying a period where it has, it's not just kind of a niche pastime as it has been in the past, and these gaming platforms are becoming useful not just for the games themselves, but also as platforms for expansive worlds and all kinds of applications. the word applications comes with so much baggage, it's difficult to use in this context, but all sorts of different things you can do in the context of a gaming engine. So gaming is another piece. And there's lots of others, right? But these are the sort of the things that sort of are to the fore, and with the technologies of AR and VR, these are the things that we're seeing. I want to just talk a little bit about Web 2.0 and the sort of the initial internet, because I think it's really important that we consider the implications of privacy when it comes to the next generation of internet and engagement technologies. The internet, Web 2.0 was substantially about ads and devices. And if we think about Web 1.0 as being kind of static web pages accessed on a browser on a computer, Web 2.0 became a much more dynamic environment, a lot more video, and with a wider range of devices and a wider range of services. And the two commercial models that drove that were the device sales themselves, but also advertising. And both, to an extent, were enjoyed something of a symbiosis. They were quite connected together. And the advertising business and Web 2.0 was wildly successful, so much more successful than Web 1.0, but primarily because of this slightly insidious advertising model, which traded identity for services. And so, you look at those services on the left-hand side, you look at, Google and LinkedIn and Bing and Google, Facebook. And there were social networking services and search services and email services and all that kind of stuff. They were really useful for people, but of course they were traded for identity information and so on. And that was then converted into ad dollars. And so that was the model. And there's been a significant pushback against that in the last few years, where we've seen privacy laws being advanced all over the world, not just in, obviously in Europe, where I'm based. We have the General Data Protection Regulation, or GDPR, which is very important. It is evolving. The Digital Services Act just came it became law on the 16th of November, just a couple of days ago. And there are more coming down the line. There's the Data Act, there's the AI Act, and a few more in Europe. But Europe tends to lead the way on these things for various complex reasons, a lot of them to do with international politics and trade, but some of them to do with consumer protection as well, and a recognition that we're entering a new phase. And that's part of it. But that is a reflection of public concern with privacy and with protecting their own data. There was some work done a few years ago, and Shoshana Zuboff actually wrote a book called Surveillance Capitalism, and quoted some of this work around young people's attitudes to privacy and so on. And it's continuing to evolve, obviously. And there had been a suggestion that young people really didn't care about privacy, and that's why all of these things were thriving. And the research suggested that, contrary to that, what it was in fact the case was that they were very conscious of privacy and were just choosing to work around it. And so, the old joke back in the day was that, they weren't on Facebook because that's where their parents were. And that continues to be the case, that there's a kind of an innovation in those younger people who, as they grow up and so on, they begin to learn more about privacy and managing their own environments and so on. So as we get this to work, so as we think about privacy in the context of the metaverse, and as we get beyond that whole Web 2.0 model, we're starting to see privacy being realized in things like Web 3. And Web 3 is a bunch, again, similar to the metaverse, and it's often used, it's often synonymous with the metaverse, and sort of Web 3 and the metaverse go together. Web 3 is a bunch of technologies that really advance the interests of privacy and security and control. It embraces the idea of distribution, and that's perhaps I mean, we'll talk about that in the context of the metaverse next, but it's the idea of distribution is usually not something that's, or distributed architecture is not necessarily something that is talked about a lot in the metaverse, but in Web 3.0, it certainly is. And the idea is that control will be distributed, that it will be broader based and so on, but also that this will be a very private environment, a very anonymous environment. Crypto plays a part in it, and the idea for you to control your own data, to control your own identity, to make sure that to control who has access to it and so on and so forth. It's not necessarily going to happen that way. I'm a little bit skeptical about it, and other people are too. But it is important to recognize that it does reflect the direction of travel. So, you know, all of that managing of individual identity and all that sort of stuff, it sounds like a lot of work, to be honest. And I'm not convinced that people are going to use all of these kinds of tools, even if they're available to them, and even if they're legally mandated to be available from service providers and so on and so forth. So I'm not sure how that's going to play out. But as I said, it is very reflective of the direction of travel. We are becoming more conscious of privacy. And when I say we, I mean everybody, suppliers, consumers, regulators, governments, and so on. Everyone is becoming more conscious of privacy, and we want to include more privacy and more control for consumers. And that's certainly the direction of travel. So thinking about the metaverse and what it actually, what the technologies then that is going to bring, we can draw the analogy between Web 1, Web 2, and the next generation that's coming. And if you look on the left-hand side here, you know, we've got layers of opportunity, if you like, in Web 1.0, Web 2.0 that are analogous of what's coming in the metaverse. And so in the original internet, you know, at the top, you've got web pages and apps, you've got smartphones and devices that run those web pages and apps, you've got platforms underneath that for gaming, retail, and other things. So think about Amazon.com, think about Steam as a gaming platform and so on, operating systems underneath that. And then the cloud, the hardware, the infrastructure, the networks, and so on, all of that underneath that. And so for the metaverse, it's pretty much the same, slightly different implementations, but the same general categories. So you have this idea of an experience continuum, which is the space in which your applications, if you like, your metaverse applications get developed. Lots of interaction with and lots of services. It's a mashup of different things to allow core applications to be delivered. We've got the human-machine interface, so we've got those headsets, we've got all these different technologies and so on. We'll talk more about that in a minute and how that's realized. And then we have this extended reality, or this idea of taking the events of reality, or the experience of reality, and extending that into the metaverse. So your shopping experience, your banking experience, your, you know, whether that's a website type experience or whether it's a branch experience. And in many respects, the website tries, and the app tries to reflect how humans would behave in an in-branch or in-store experience, but it's very limited by the human-computer interaction restrictions. Right, you're still typing on a keyboard. Generally speaking, there are some voice interfaces, but even those tend to be challenging. There's some chat interfaces, and again, they're very different. The metaverse begins to make it much more like that branch experience that we had pre-internet, or the in-store shopping experience, and so that's a key part to that. And then the world engine, if you like, is that platform that the metaverse operates, the core metaverse that enables other services to be deployed, that can build those things in the higher layers, and then infrastructure is still infrastructure. So there are some uniquenesses to how the infrastructure is going to be consumed. We're still talking about silicon, we're still talking about compute storage and networking, but we're going to see different pressures brought to bear on it, and I'll talk a little bit about that, particularly as it applies to telco in a couple of slides' time. A key message that I want to just dwell on for a minute is that there isn't just one metaverse. If this is kind of like a multi-metaverse, if you like, the multiverse of metaverses. I'm not sure, I haven't got that phrasing right, but we'll figure something out. I think it's highly unlikely that Meta will own the metaverse. I think Meta clearly has been doing an outstanding job at investing in the metaverse and metaverse technologies. But in the same way as nobody owns the internet, nobody's going to own the metaverse, in my view. And once you accept that, you start to think, well, what can these metaverses look like? And so, you can have different DAOs in Web3 terminology, these distributed autonomous organizations that manage the environments. You could have a metaverse for children's content run by Disney. Perhaps it's just Disney content, perhaps Disney facilitated and it is engaged with by other providers of children's content, not unlike a kind of a Netflix environment, for example, which is more for general video entertainment, but at the same time they bring in productions from other places and they just facilitate they have the platform, they have the environment. Similarly for BMW, you might think, well, suppliers, customers, employees operating in the metaverse, even the mechanics network and things like that, collectors, all sorts of different members of the BMW ecosystem participating in that. Healthcare, again, major brands like Mayo Clinic, for example, might want to build a healthcare metaverse. And then for the service providers, I've got AT&T and of course Axiata Group, there are uniquenesses there. So AT&T is particularly American. Axiata has its Asian properties in 6 different countries in the telco sense. And, operating in those environments can provide a B2B service that has a localized function that is, adopting localized compliance requirements, perhaps along the lines of some of those Web3 technologies that we talked about that are legal in the countries in which Axiata operates, and providing certain levels of assurance that, compliance will be adhered to in those areas. And so that other brands and businesses operating in those countries can have a metaverse presence for those for customers in those countries. So there are potentially going to be different metaverses, and this aligns very well when we think about the telecommunications B2B strategies. We're increasingly, historically, telco B2B has been about, volume SIM cards delivered into large enterprises. Today, we're really seeing, in the era of 5G, and I don't just mean 5G technology itself, but I mean sort of advanced wireless technology and wireline technology indeed. Service providers are no longer saying to their enterprise customers, please connect your stuff to my network. Service providers are now saying, please build your applications on my platform. And that means much more than simply here's a bunch of SIM cards or connections that you can use. It means we've got these edge processes, these edge functions. It means we've got these data services that you can get access to. We've got these IoT products that you can use and so on. We'll talk more about that shortly. So that's the context within which we're thinking about the metaverse. We're thinking, okay, if we've got these services, can we build them out for can we sort of construct a metaverse that contains these products or facilitates these products or is facilitated by these products? There's a connection to them. one thing to realize about the metaverse is that most of the apps are indoors, and that's really important. When we think about the telecommunications industry, apart from, there are a few applications, say, HUDs or heads-up displays in cars and things like that, they will require wireless access. But generally speaking, most of the applications are indoors. These ones that I talked about earlier, the real estate, the meetings, the gaming, the retail, and healthcare too. These are applications that are performed indoors, and so we're really talking about a number of different access technologies. I think a lot of them will be wired technologies. Even with the headsets. If any of you out there is into gaming and likes to play immersive video games, World of Warcraft, or I can't remember the other ones now, but these immersive first player games and so on. If any of you are serious about it and you get some kit at home, I'm sure you will say that you prefer the wired interactions and the wireless interactions, even just talking about Wi-Fi versus USB or whatever the connection happens to be. Because they're just more reliant, they're more resilient, they're more robust. Advanced wireless networks are very, very good now. But when it comes to those, fraction of a second type reactions and things like that, the wired connections are much better. So we're going to bear that in mind. Now, you may still have, 5G, 6G backhaul or whatever, wide area wireless network backing off the data. But when it comes to the actual application indoors, it's going to be probably a wired connection. And so then when we consider the different components for the metaverse, and how the services are going to be delivered, you have all of these services on the left-hand side, and you've got your edge devices on the right-hand side, and this is just a very similar service delivery kind of structure. You've got your in-building router, your home router, whatever. You've got a base station or a cabinet. You've got the data center, and you've got your backhaul, your last mile, your cable, your Wi-Fi. And you've got to think about, how the metaverse services are going to be delivered. If you think about those services that we talked about already, and think about gaming and retail and healthcare and so on and so forth, we're going to have a lot of real-time bidirectional streaming. And that's going to put particular pressures on the network at different parts of the network. Not only that, but we'll have to have self-correcting mechanisms and self-healing mechanisms that we're developing a lot of right now in the context of virtualized network infrastructure. And this infrastructure that you see in front of you, some of it will be virtualized, some of it won't be. There needs to be some physical stuff in there, of course, but the point is that the software that manages it is going to be increasingly automated, and that's going to require a lot of data. So we have to think about how we run these applications and where we run these applications. If we've got real-time streaming and we've got a dependency on low latency service delivery, then we're going to have to be very, very agile in our response to network degradations or service degradations. So that's a really important piece for us. So thinking about it in this way can sort of help us to think from a network perspective. Let's divide it up and see where the potential failings. Do we need to run automated service assurance in the base station? Do we need to run automated service assurance even in the in-building router environment? So a lot of companies now have, a lot of service providers have edge analytics inside in routers that are useful for diagnostics and so on. Do we want to go one step further and actually have remedial diagnostics and actually start to fix things and auto configure devices to respond to changes in the environment or the demands of metaverse service delivery? And then this is kind of the last slide on the metaverse piece before we actually get into the data piece. I just want to point you to the link on the bottom right. We did a webinar a few months back with an analyst called Dean Bubley, and I believe there was a representative of Axiata on the call actually. and do in Dubai. And we talked about opportunity enterprise data in the 5G era, and edge is something that, I mentioned it earlier, and it is something that is hugely important for advanced computing generally and the metaverse specifically. So, again, like I mentioned there just a minute ago, putting remedial analytics into the router is something, putting remedial analytics into the devices themselves, is that something that's going to be possible? Certainly it's something that we'll need to think about if we want to have optimal service delivery. And so, but all of these different types of edges can be converted into quite active components of the network from a service assurance perspective. So they're already active in terms of networking and routing and so on, but can they become more active in terms of service assurance? That's a big challenge. So what does all this mean for data? And so I'm going to skip through the last few slides fairly quickly, but I want to sort of give you a picture of the data environment. And so first of all, we've done a little bit of a history of the internet and sort of how we've come to the metaverse. If we think about big data, we started off in 2000 by putting IBM and Oracle software onto very expensive hardware. It was very slow, very, very expensive. And we evolved that so that the software began to be written specifically for the hardware. And so we found ourselves in a kind of an applications or an appliance standard. And that made things more efficient and faster and so on, but it was still very expensive and still relatively slow. Big things happened in 2010 or over the next 5 years or so, where we had significant, there's a number of different things happened. The open source community began to develop and deliver software that was production ready for very large enterprises at scale, and data design, data architecture technologies changed. We moved from structured relational databases into file-based systems and all sorts of other things. And also, very importantly, China's accession to the WTO in 2001 meant that storage and compute costs dropped dramatically over this period of time. And so suddenly we'd moved beyond the space in 2000, 2005, where we were, maybe able to do some management reporting, some compliance reporting, some regulatory reporting. Now we were starting to ask questions about behavior, and we could begin to model behavior. And so that meant, and that happened at the same time as the Internet 2.0 and ad tech and so on, as the advertising business began to take off. So it was a really exciting kind of a time. And that's when Cloudera was founded. Many of you will know Cloudera as one of the founders of Hadoop and the Apache open source ecosystem. And that's where our business came from. But our business has evolved very significantly, as I'm sure you're aware. And by 2015, you had a change again. So having skipped from relational appliances into open source file-based solutions and so on, now we were looking at the public cloud and what the public cloud could actually deliver. And you had obviously Amazon, probably the leader at that stage, and then with Google and Microsoft coming along, and Cloudera was developing its own cloud technologies at that stage as well. And then if we fast forward to today, we've got cloud native solutions. As companies like Snowflake, Databricks, Cloudera has its own cloud services and hybrid services and so on. And there are others. And lots of other tools besides, right? So advances in governance, visualization, AI reporting, and so on. The question is, where are we going to be in 2025 and beyond, and how are we going to support the metaverse? So if we think about this journey to cloud in particular, and I know this experience is a little bit different in different parts of the world. Telecommunications companies are looking at this and saying, okay, well, we should really shut down the data centers, move everything to public cloud, if it's possible within the jurisdiction. And so there are strategic partners that are sought. So it could be AWS, could be Microsoft, could be Google, could be a local partner. But the problem is that there are already partners in place. So we're already running applications on virtualized infrastructure in the data center. Here we've got customer data and the CRM team running something on Red Hat. there are different applications in different parts of the business running potentially on different clouds. So if someone goes off and buys a customer management system that's compliant or that's certified on Azure, but not on AWS, then that's, you got to run it on Azure. And so you select Azure. Similarly for Google, for Amazon, for whatever the platform is that the application is certified on. So there are already partners that have decided to operate on specific environments. And we've got to take them with us. Different workloads, different infrastructures support different workloads. This is a really important point as well. We might have certain workloads that that require GPU accelerated infrastructure. And so, we'll have that set up there. We may have certain workloads that need to be in jurisdiction, that need to stay in the country. And so we may have that, that'll be a specific data center type application. And then we have other infrastructures that support different kinds of applications. Like I was saying, certain applications commercial applications that you might buy might only be certified on one cloud or another, and you have to buy that capability. And different data sets have different demands as well. So you've got personally identifiable private information, that's important, healthcare data, federal or government data. They'll all have rules around how they're consumed and how they're processed. And so where we see this going and where we think that the infrastructure is necessary to support the metaverse is what we call an open hybrid modern data architecture. The metaverse is going to have so many different data sources from so many different service providers. Some of them are going to be public clouds. Some of them are going to be on-prem. Some of them, the metaverse in essence is a mashup of lots of different data sets. And in order to provide services, we're going to need to be able to manage all of those data sets. And so three key elements to this. There's the data fabric, the data lakehouse, and the data mesh. And they constitute a modern data architecture. So we've got to move away from this idea of saying, okay, we're going to have this big storage environment here. We're going to dump everything in there, and then we'll figure out what we're going to do with it. And that's kind of been the paradigm for the last 10 years or so. So we build this big data lake, and then we'll start building interfaces and integrations and so on. We really need to start thinking about, how our data platform extends to the edge, how our data platform supports AI and automation. These are key questions to being successful in the metaverse. And if we think about in today's terms, why these three things are important, the data fabric is important because your data is all over the place. These are the common complaints that we get. I don't know if I'm compliant. This is a question this is the challenge that we get a lot, because people are saying, it's not just that I'm not compliant or I am compliant, it's that I don't know whether I'm compliant because I can only see certain pieces of data. So your data fabric needs to work across all of your data sets. The data lakehouse is this idea that your platform is much more than simply a data warehouse or a data lake, or a data warehouse and a data lake. It's much more than that. It's recognizing that your data platform needs to incorporate other data services, things like edge processing, things like data flow, things like AI. Those services need to be part of your data platform that is then exposed to the rest of the business. And then there's this idea of a data mesh, which recognizes that businesses need to treat data as a product. And so businesses all the time create new products, but they don't think of data as a product. They think of data as something that supports their business. And because it's that kind of a model, they're going to the CIO saying, I need this new data model, I need this new data set, and so on, and say, fine, join the queue. And that's a real problem. So in order for businesses to be successful, they need to treat data itself as a product. And that kind of approach leads to different kinds of architectures. So let's look at a quick example. So let's say we've got some data on some proprietary data on Ozone sitting on-prem. We've got some customer data on AWS. We've got some advertising data on Google. And we've got some machine data, some IoT stuff on IoT. On Azure. So if we have all of these pieces in place, they're not talking to each other. They're on different platforms. There could be some redundancy. But we need to, if we put in place a common data fabric, we can begin to unite all of those pieces. We don't necessarily move them. But what we do is we create a logical platform that connects all of them together. It means that we can begin to move workloads between different infrastructures. It means that we can access each of them. We don't even have the edge cloud here represented in the graphic, but that's another place where we can push applications capability into the edge. And then once we have that fabric in place, then we can think about, well, what sort of a feature set do we need to have available in each of these environments? And you start to think about, like I was saying, AI, machine learning, operations support, edge capabilities, and so on. So those kinds of capabilities will significantly enrich what's possible with the data in our business. So I want to leave you with this quote. It's not specifically about the universe, but it is talking about this future data ecosystem, and I think it's really important. We're going to see lots of clouds. We're going to see lots of environments, lots of infrastructure. We're going to have lots of capability in different places, and we need to manage them all. We need to treat them as a cohesive whole logically. This isn't a single platform physically, but it is a logical data platform that supports the business. We need to think about how we manage across these different environments, these different data sets with their different requirements and different restrictions and limitations, and pull them together. Otherwise, we'll be scrambling around, with different governance regimes and different compliance regimes and so on, and it'll become a far less efficient organization. So the metaverse brings forward enormous potential. The technologies in there, they're already there today, but they're coming together in a way that's going to be really, really interesting. And as a business, as an industry, we need to consider how the data from the metaverse can drive automation and new services. And that kind of a modern data architecture is going to be essential for that. So thank you all very much.
Okay, Anthony, we have a question for you. How costly it is to get into Metaverse today for a business? Can tech startups convince investors for ROI today, or should they wait for another year?
Well, I think the answer is that it depends on what part of the Metaverse you're looking to get into. I think developing applications for the Metaverse is important. There is a question about when you're going to start generating revenue, and that's a little bit difficult. Don't just think of the metaverse as one thing. Think about it as a sort of a sequence of technologies that are going to come to fruition over the next few years. And an exclusively metaverse-driven or VR-driven application, for example, that's a little tricky. Try and have a sidecar business that sort of, if it's going to be in the banking area or if it's in the telco area or something like that, make sure that there's something that can be relevant sooner than the full realization of the metaverse. So watch your timing and try and get to revenue as quickly as possible. That'll be my advice.
So Anthony, we have got one more question from the audience. Metaverse will need to handle a massive amount of data for AI and ML. Have thought about some advanced data compression or pattern serving techniques rather than sorting all the data?
Well, I did mention a couple of times that edge technology is going to be really important. And edge technology is not just about data collection and data processing, it's also about machine learning and sort of pushing machine learning to the edge so that you can you could basically have as much processing as close to the data as possible is going to be really important. And that's really what we're talking about when we talk about a modern data architecture. You need to distribute your data processing as widely as possible. Compute is going to be available much more broadly than has historically been the case. So we don't just have to bring all of our data into a central location and then start to run those workloads. So it's going to be a much more distributed environment in which we run our models.
Well, thank you, Anthony, for that insightful session on the data architecture for Metaverse.